Well, hello everyone. We might as well get started. I'm Mike Bowers. I'm with the LDS Church, and this is it's going to be wild. I'm going to be walking back and forth, I guess. This is a very wide room. Okay. I'm a principal engineer at the LDS Church. I've written a couple of books. As you can see from the title of this book, I'm a developer, CSS and HTML. Most of my career has been in software development. The last 11 years of my career working for the church, I've been a data guy. Now, I'm a data-oriented person from the very beginning, but I love writing code, and so I started off writing code, and now I've been doing data for the last 11 years and doing a little code, so I kind of flipped. I'm a very data-first kind of guy, but you can see I love CSS, HTML, I love web development, I love back-end development, kind of like everything if it's computers. I build computers, done infrastructure. By the way, one of my fun things, I just finished last year designing a replacement for Exadata. We have Exadata for our data warehouse, and I engineered a solution that was faster than Exadata, and we built it, and we succeeded and replaced Exadata. So that was fun. I'm like Chris, I love to get down into the dirty details of the hardware and make things happen. So I really enjoyed that. The Church of Jesus Christ of Latter-day Saints or the Mormons is a big church. You can see 15,000 congregations, 15 million members, 30,000 congregations, thousands of documents in 188 languages. But what you don't know is we have over 350 servers running MarkLogic. 350 servers running MarkLogic and over 200 applications. Isn't that crazy? 300, and we have, and they cover all kinds of range of use cases. We cover, the vast majority of them are websites. That's where we started back 11 years ago, building websites in MarkLogic. XML database, XML app server, fantastic use case for building custom content management systems and building custom websites. So we have hundreds of websites, billions of page hits hitting MarkLogic. So that's been very successful. But from there, we started branching out and we started building transactional systems in MarkLogic. Right now, one of my favorite ones is the church history. Our church history department collects artifacts from all of our history, books and people who wrote things, letters, watches, anything you can imagine in a museum. We've collected it about church history from our entire history for the last 200 years. So they have to catalog all those things. And that system was originally written in Ex Libris, which is a library management system, and librarians cataloged it, but it's really hard to search. You can talk to a librarian, they'll find it for you, but if you want to find it, you can't. It's not self-service. So we're completely rewriting that system right now in MarkLogic. It's fantastic search, metadata management, great use case. Our policy management system for the church is written in MarkLogic. We're now rewriting the system that schedules all of our leadership is being rewritten in MarkLogic right now. So that's our prophets, our church ecclesiastical leaders, our bishoprics. They all run their schedules and they make minutes and approve, like your CEOs make a minute and they decide something, right? And it's official, it's a memo. That system is being rewritten right now in MarkLogic. MarkLogic is 1/4 of all of our databases in the church. And we have thousands of databases. Oracle is 1/4, SQL Server is 1/4, and MySQL is 1/4. The funny thing is MySQL is unofficial, unsupported, and never supposed to happen, and it's 1/4. So that's because of open source. It just happens, and you can't stop it. So anyway, we have a big IT department, just to kind of set we have thousands of people. We have, so it's a big group, and we're not like a little church on a corner, right? We're a central international organization, just to paint a scope size for what we do. So what is a data hub? There's an article written years ago by Dr. Malcolm Chrisholm, and he is back in 2008. So that's when I wrote my book, or published my book. That's a long time ago. And he talked about data hubs back then, and he did a great job. So I'm using his stuff. So he says a data hub is data from one or more sources, and you send it to one or more destinations, right? Real simple, that's easy, but that means it could be almost anything. That's a database, actually, right? That's what but the idea is you collect data from different sources, and then you deliver it to other sources. But there's a couple of things that are happening in the enterprise today. Come over here and give you guys some attention. This is like 4 rooms in one. It's awesome. So the more data that's in an enterprise resource that needs to be shared, the more likely data hubs will appear. Why are data hubs growing up? Because of hairballs. You know, have you ever seen a hairball? Or think of spaghetti code, or think of those big rubber band things, right? The enterprise over time is collecting hairballs. We're growing them. These are integration nightmares where we have stuff all over the place. And when you create if you want to detangle the hairball, you need a hub. Basically, you take all the stuff that's going throughout the maze and bring it into one place and deliver it from one place. The hub and spoke model is perfect for detangling hairballs. So he's saying we will get more of these things. Data can be shared, but if you do it through point-to-point, you're going to create more spaghetti or more hairballs or more of the rubber band problems. So the D hubs are the detanglers. Data hubs are detanglers. Now I'm out of range. So he calls it a nicer word than I do. He says gigantic spider webs. That's a little nicer. I guess I just pulled a Gary Bloom and called everything cesspools by saying hairball, but anyway. Okay, so to replace these gigantic spider webs of real-time APIs, which are like SOAP, REST, and database links, the idea is you centralize into hubs. So he talks about, in his experience, point-to-points, which are not only REST point-to-points, but also database links. And if you ever thought about a database link is identical, except for protocol, to a REST endpoint? Now, in some ways you could say, yeah, well, the REST abstracts it. Well, in my database link, I put a view. I just abstracted it. I could put a SQL stored procedure in my database link, and you hit the stored procedure, and that's identical to everything. I have business logic, I get everything. So we have been doing, in our organization, we have over 3,000 database links sharing data everywhere. That's a big spider web. We have hundreds of web services sharing data everywhere, spider web. And they're not integrating, they're all just messy, and we don't manage them very well. So it's a big challenge. They often needlessly replicate movement of the same data. So here's real-life stories. REST endpoint, we have a membership system that has REST, and the only official way you're supposed to get data is through the REST. People do get database links and get it that way too. But we go through REST, and people think that the team that gives this REST data out assumes that people do it play nicely with it, that you'll call it onesie twosie when you need it, real time, right? If I need to look up a member, I pass the member ID in, and I get the member data out, and I do it on demand. That's the way you're supposed to use REST. What do we actually do? Well, we have an international banking system, which sounds weird, but the church does, because we collect tithing funds from members, and we're very careful about managing those. We never want to lose not a penny of money. So we manage that very carefully. That international banking system goes and talks to our member system. And it's because the member system, since the banking system can never go down, you can't rely on the member system REST API being up. So what does it do? It goes to the REST endpoint and sucks all the members down and puts them in its database, because then it's highly available. It just replicated the data. So every time, and we don't do that just once or twice in our organization, we do it over and over again, right? So there's a mirage, an illusion that when we have REST, we're not moving data. We're moving data all the time. We're copying the entire sets down on a regular basis. And think about the development work you have to do in an organization when every developer is rebuilding a replication solution, right, from scratch. They're going out to REST endpoints, figuring out how to go suck the data down, persist it in their database, model it in their database, doing all that work. It would have been much better to just have a database link and just do it. Oracle will do that automatically. Create a materialized view on it and be done. Why are we writing code to do that? Because we want data in our databases. Another reason we want data in our databases is we want to join with it. So I pull that data down into my banking system, and then I have millions of records. You can't join in REST. You can't join across REST services. You can pull down all the data into a database and then join, right? Index it. So what do? They pull it all down, index it, and then join it with their own data. So we move data, no matter what you talk. I talk to our REST folks, and they say, we never move our data. And I go, yeah, let me show you. We're moving it every time because we want in our databases to join it. We want high availability. We don't want to trust the source. These are reasons why we copy data. So we needlessly replicate movement of data, but I actually disagree with this word needlessly. I think it's legitimate to say I want to join data. I think it's legitimate to say my source is unreliable or not reliable enough for me, and I want to be up, right? So that's not needless. Now think about your bodies. Think about every cell of your body. What does every cell of your body have in it that runs the cell? Mitochondria. Very technical answer. Is that what I heard? Yeah. And DNA, and right? How redundant is the DNA in our body? My goodness. Every single cell, that's needless replication. Get rid of it. All right? We should go to the brain every time every cell wants to do anything and get the result and bring it back down. That's rest, right? Our bodies are so restful. Not, right? We replicate the code, we replicate the data in every cell of our body so that we are redundant and highly available. I'm grateful, I'm highly available, right? That would not be nice. My hand just falls off. Oh, sorry about that. The rest surface of my ear went down. Okay. So the other thing about this is poor governance. We don't govern REST very well. We, in the church, we implemented data API Manager from MuleSoft. And no one wanted to use it. So then we were writing our own custom one. The point is you try to govern things, and the real answer is why do they want REST? Is because they don't want to be governed. They don't want the database guys telling them you can't have the data. They want to be free. The movement is not, it's not that developers are bad. I am a developer at my core. I'd love to be free, right? I'd love to just do what I want to do. I hate to be told, right? That's why I love computers. They just do what I tell them to do, right? So now I have a manager telling me what to do? I don't like it. So I want to be free, but we need to govern everything. Typically difficult to modify, typically poorly documented and understood. These are all REST endpoints or SOAP, same thing. Message queues, same kind of thing. They promote coupling. Now think about coupling. We think that REST decouples. It decouples in the sense that I abstract my database away. All right, I'm hiding my database underneath my REST endpoint. That's good because I don't want to. I want to be able to change my data structures and stuff underneath and not worry about that. I like that. But if I have a REST endpoint here and an app here, and this app has to go to the REST endpoint every time it wants to get something. Like every time it wants a member information or a customer information, it's calling over here and getting it. Is that tightly coupled? Yeah, super tightly coupled. If that REST endpoint goes down, my app's down. So how do I decouple it? I need to put a cache in between. I need to do something to decouple. REST decouples the technology. I'm not tied to Oracle's proprietary connectors and SQL servers, and I'm not tied to, but HTTP is generic, so I can do that. I like that. I like the fact that I'm decoupling the code, right? I like that kind of abstraction, but I'm highly tightly coupled still. Database links do the same thing. This is my aha moment years ago that database links and REST services are functionally the same thing, and developers hate database links, and it's just because it's not their thing. I mean, just be honest. So I want to say that REST is absolutely as bad as database links. They're not being governed, all these problems. But data hubs can solve this problem. Obviously, where I'm going. Okay, the next thing is, and REST, like I said, every developer is writing their own code to bring the data in and integrate it into their system. So it's a nightmare. So here's what I'm proposing. This is what Dr. Chrisholm did. He came up with 6 flavors of data hub. I'm going to talk about the 6 use cases of why they exist. The number one is one of my very favorites. It's the pub-sub model. The idea is you publish your data to some kind of hub, and then somebody else comes into the hub and subscribes to it. That means there's something in the middle, and I drew it as a database picture, right? So you have a cache. You have a persistent store in the middle that is decoupling the source from the consumer. Right? That decoupling, it gives you high availability, and it allows you to do value add, because you can do stuff in that database to make the data better, to make it queryable. I'm going to throw this out now. We'll come back to it a little bit later. Imagine, how many of you have built REST endpoints before? Just raise your hands. So a lot of you. Okay. So I just offended all of you. That was awesome. But I'm a developer, so I can defend myself. I built lots of REST endpoints, and I use MarkLogic to build REST endpoints. I've done them in .NET. I've been a .NET developer most of my career. So, and before .NET, I was Microsoft, so I did all the other Microsoft technologies. I like to build .NET and REST interfaces, but now I lost my thought. I did lose it. It's gone. That's wonderful. So I built a REST endpoint on my. Oh, here's what, queryable. How many of you have built a queryable REST endpoint? Okay, you guys have built it. Was it easy or hard? Oh, you built the queryable REST endpoint on top of MarkLogic. That's easy. Okay, now how many of you built? That was not fair. Yes, it is queryable on REST on MarkLogic's easy. You can build queryable because MarkLogic is a queryable REST endpoint. It's already built. They've already done the work for you. Now, how many of you built a queryable REST endpoint on Oracle or SQL Server, some SQL database? No one? Maybe you have?
But I'm not sure if it's a REST endpoint. I use GraphQL, and it was actually easy over HTTP.
Okay, so GraphQL helps.
You can do whatever you want.
Right.
GraphQL is very, it has a specification. You have to follow the rules.
And the reason why GraphQL works is because it's not queryable, it's structurable. I'm going to say it another way. So GraphQL sounds like it's query language, so it's called graph query language, right? But GraphQL, it's not even graph, right? It's not even graph, and it's not even a query language. So, but I like it, so don't get me wrong. What it is, it's a shape language. I go call a function. It's a remote procedure call language that gives you back, that you define the shape. You say, call this function, and then I want you to return this shape back to me. So it's a way of subsetting the data back, but you're calling a function. Calling a function is remote procedure call or remote method invocation. So GraphQL is a way to call methods remotely, but that's not a query language, right? You're building the procedures you're calling, right? That's not what query language is the end user can pass anything they want, like SQL in, or MarkLogic's, you can pass a composite query, you can pass in one of the query by example, and then the database interprets it, runs queries, and then returns the results, right? So dynamic queries. Writing a dynamic query language is hard. MarkLogic's done it in their REST API. If you use their APIs, you can build it all day long. You can build dynamic queries in REST. That's awesome. I'm doing that right myself. I'm creating my own query language that's a hybrid of GraphQL and OpenAPI and several other things, so that I can have true query language, true shape language, and have queryability. But if I do a queryable REST endpoint, it's incredibly versatile. Anybody can use it for anything, right? GraphQL is taking off like crazy. It's a wonderful API because it's simple, right? And it's practical, and people are using it like crazy because it allows the developers who consume it to define what they want, exactly what they want in terms of the shape, and they get back what they want. And it can reduce a lot of round tripping. We have in that banking application I talked about, we just rewrote, it's a Java app, we rewrote the REST endpoints to be GraphQL because what they were doing is they were calling a whole bunch of different endpoints to get the few pieces of data they needed, and we're stitching them together. And we were having hundreds of thousands of redundant, unnecessary REST calls to get all the data they wanted. And in GraphQL, they could say, here's the function, here's the shape, and get it with one call. So queryable, flexible endpoints are the name of the game in the future. So this data hub, if you had a queryable REST endpoint in a data hub pre-built for you, just sticking it in front of your source gives you instant queryable results. You've added value. Think about that for a second. You can load data into MarkLogic. MarkLogic is a REST endpoint. If you stand up MarkLogic, you have REST. It's built in, right? You throw data into MarkLogic, it's instantly available through REST. MarkLogic has element level security. It has it's like, I call it cell level security. You can intersect the row and the column, or intersect the document and the property, right? Or document and the element, right? It can give you the granular security out of the box. How many of you tried to write REST endpoints that had that level of security in them, cell level security? How many have written that before? We have a team that spent 4 years building that in Java. And they call it the Enterprise Service Framework, and they did a really good job. But it's a framework that you have to go apply. MarkLogic, I just send configuration into the database, and I have element level security. Think about, you just stick MarkLogic in front of a REST endpoint, you immediately get queryable, You get cell level security. Huge value adds that are very expensive for you to build. And all I had to do is stick it in front of a REST endpoint. Another use case, operational data hub for integrated reporting. And this is more of your operational data services database where you pull in lots of data from lots of sources, combine it together, and then you do reporting off of it. It's not the same as a warehouse. It's more operational reporting for an application. And these are all Dr. Chrisholm's 6 concepts. Next one is data warehouse. You do the same thing as the operational reporting, but this time it's going into a data warehouse. The difference, the data warehouse is caching it again, right? And restructuring it to be in star schemas so that your reports are pre-built and your analytics are super easily consumable. And then fourth is master data management. We've heard a lot about that here, right? Notice there's a person involved. Master data management requires user interfaces and people to interact with the data and find the problems and fix them. And the software gives you tools for the people to discover the problems and do golden records. And the reason why master data, in my opinion, master data management systems fail is because either your source data is so bad you can't do anything with it, or the people aren't effective at making it happen. And it's not a technology issue, it's actually more of a person issue, honestly. It's hard to get people to agree on a golden record. It's hard to get people to agree on anything. And organizations that don't have that will to come to an agreement fail. Or your data's so bad you just can't reconcile it. The message hubs, some people would say that's not even a hub, that's a message queue. But when I talk to our enterprise service bus team, absolutely that's a hub to them. In fact, they believe that is the only pattern. In our organization, they would argue that every other pattern I'm talking about, using a database is evil to them. They think databases ought to be banned off the face of the earth. They think everything should just be messages flowing between systems. And you put a message queue in the middle, and it gives you the ability to guarantee delivery, and it decouples. So it really does a lot of value. Remember REST to REST is tightly coupled, right? You put a message queue in the middle, you've decoupled, and you guarantee delivery. And you can go asynchronous, and you can scale. They're fabulous. They're wonderful. They're not databases, right? They're not queryable. They have limited security. You can filter what goes through them. You have a message, and you can filter what's in the message. But you can't filter a message based on other data that's outside the message, because it has to just look what's in the message and see what it can filter. So it has limited filtering capabilities, but it's powerful. It's a hub model. It's what Chrisholm said. But I don't usually think of it like a hub, but I promise you, your ESB guys or your message queue guys are like, that's the answer to every problem there is. I think it's hugely valuable. And the next is the integration hub. This is your real-time or batch hub. And that way you pull everything in. And notice the arrows on all these things. And the first one, you publish into it and they get data out. In MDM, you can go in or out. In MDM, it goes in, goes to people, and goes back out. But I didn't draw it this way. It flows left to right. But you can have an app put data in MDM, and it could go right back to the app and fixed. You can fix the data and send it back. MDM updates things. So sources can be updated by themselves. So these things, the arrows matter if they're flowing left to right, but you can see that the different use cases have different data flow patterns. Like the data ends up in a warehouse in the last one.
I have a question.
Yes?
The message hub. A message hub for a certain amount of time can also be used for batch, like this. So because you can post message hub as the technology to replay the last 24 hours and some up to 7 days.
Yes, there's a really cool feature in message hubs where you can cache the history of everything that's happened and replay it from a certain point in time. And in that sense, it's kind of like a database in that you've persisted something.
Not as a database, just that you can replay and then you bring it to a database.
And then you bring it into it, but it's just a message hub. But the point is, it has a database in it, and it can store things that happen, and you can even have multiple consumers at different points in the queue pulling things out and replay messages. You can get really fancy. I like message queues. They're super powerful pattern. Yeah, they're not a database. You don't query it, right? It's not a queryable system, but it is definitely a way to communicate, integrate.
Not querying, but PubSub.
Yes, it's good for PubSub. And PubSub Chrisholm separated the two. PubSub and message queues are often synonymous, but they're not. They don't have to be, right? They can be separate things, and I'm showing them separate. So now let's talk about what MarkLogic can be used for. The first AMP is one of my favorites, PubSub. That's the one I said you just stick it in front of your relational data. You stick it in front of your app server REST endpoint, right? So you have a REST endpoint, and now the trick with this model is you make sure that the app is pushing all changes into MarkLogic. So there's 2 common patterns to do this. One is the app is making changes, and it hits a trigger event. Oh, I made a change. Now it could take the data, when it writes it to its database, hopefully it's a MarkLogic database, but it might be right to the relational database, whatever it's writing to, it can take the same object and shove it into MarkLogic. Right? So as soon as it writes, it's writing both places. The reason for this is MarkLogic is offloading all the data that it wants to share. Now it may make a decision. I don't want to put everything in MarkLogic. Maybe I only put a subset of data, my shareable data in MarkLogic. So that may make some smart choices. The trick is to make sure that this cache, I'm calling it a cache, is all the data you're going to share because it's queryable. And if it's queryable, you want to get back all the data for a query. You don't want to get half your data back. Think of more caches are often just like half the data is here, and the other is in the real database, and if it's not in the cache, you go get it from the database. That's not what I'm talking about. I'm talking about all the data you're going to share is in that cache, and the app keeps it in sync, right? When you do that, you get all the benefits of now queryability, filterability, shareability, and high availability, because MarkLogic's sitting outside of the source. The source can go down, and you're still up. And scalability. MarkLogic can replicate to many instances. So you can have MarkLogic replicated 20 times sitting in front of that database, and you can scale the reads through the roof. And if you know MarkLogic's performance, MarkLogic can get documents in milliseconds. It doesn't have to, if the app is storing the actual document it wants to share, MarkLogic just has to do very little work to give that document back, right? Super fast, but it's queryable. I can put range indexes on it. I can do any kind of query you want. I can think about the search. It's searchable. Now you have a searchable, queryable endpoint. And you know what the cost was? Just pop in documents in it. You know how easy that is? In your code, that is so trivial. To set up this solution, we do this in front of our warehouse, which is another use case. We load data from our warehouse into MarkLogic right now, and it only took a couple hours. Keith here in the room, he did the project, and he stood it up. And then we had data in MarkLogic, and the customer instantly had the data. And then the customer said, well, I want a custom REST endpoint. Remember the discussion earlier today, API first kind of thing? The customer says, well, I don't want to write queries. I don't like queries. Can you just give me the data? I'll pass this into you, and give me the answer. And so he said, no problem. And in a couple hours, he had I don't think it was a couple hours, was it? 2 hours. 2 hours, he had a custom REST endpoint built in MarkLogic and xQuery, and they had exactly the data they wanted without even thinking. They didn't want to think. So we said, okay, you don't have to think, just push the button and you get it. So that's how easy this whole thing was. This pattern is so easy, it's kind of embarrassing. I mean, MarkLogic has made this super easy to use, and it's powerful, right? Think about the benefits again. High availability, scalability, you've offloaded all the work from the source. The source isn't getting blown up by getting hammered by all these queries. And remember, customers or app consumers are coming in and sucking all the data out of these REST services so they can copy it locally. That kills the REST endpoint. But they can do that all day long from MarkLogic. And if that's killing the one instance of MarkLogic, stand up another one, replicate it, stand up another one. So you get high availability, yes?
What do you mean by real time? Because REST is not real, it's not streaming. You don't get it as soon as the message comes up. You have to make a call.
So, well, in this particular use case, it's pub sub. So what you would do is the app puts it real time into MarkLogic. So that's real time, yes. Right? Now, how do you get the notification to the customer that it was real time? Oh my goodness, 10 minutes. Oh my, I'm really going slow today. Okay, so the answer is message queues. When it comes into MarkLogic, you can also publish it right back onto a message queue and deliver it immediately. You combine them. And so you don't have to use just one of these patterns. You combine the patterns. And my ultimate pattern, which now I'm running out of time, I'm just going to jump to my ultimate pattern. So I've already talked about all these things you're seeing here because I talked about the cache, right? And I talk about the cache because when I use the word data hub to a developer, they shut down. They say, data hub, you're a data guy? I'm not talking to you. that's wrong. It's just wrong, right? So you have to be API guy and say cache. Oh, cache. I like caches, right? It's very real. So I believe me, I've had many conversations with our developers on this one. They love the idea because it's performance, scale, availability. We talked about all that. So here's 3 general use cases. I've been talking about the one here where you put MarkLogic in front of your source, you cache the data, and now you have all those advantages, right? Here's another one. You put MarkLogic in the center of your enterprise and do the same thing, but now multiple apps are feeding into the same hub, right? This is more like the MarkLogic concept where you're feeding lots of sources in and you share it back out with lots of sources. But that one's politically difficult because a lot of developers are going like, I hate centralized stuff because then you're going to manage me, right? Because I lose the power to do whatever I want. I like federated. I have freedom with federation. So I've had a lot of debates. They like the first one. They hate this middle one. They think I'm taking over the world. The last one is where a consumer says, I've got all these sources, and they're all different. And I'm going to pull their data in. I'm going to reconcile and harmonize it, and I'm going to blend it with my own data. And now we've seen that pattern here at MarkLogic too, where you bring it all together, harmonize it, and use it. 3 different use cases. One is the sources sharing it. One is the enterprise combining everything into a central place. The third one is I have my own app, and I'm just using MarkLogic to gather data in one place. All 3 are data hubs, 3 different use cases, 3 different scenarios. I'm going to move quickly through these. The slides are going to be published so you can read them. Here's a really cool idea, though. The data hub, remember, it decouples and it caches. MarkLogic has replication. That means you can cache your data and replicate it all over the world. That means your hub now, that shared data is available everywhere. It's not just available in one data center, you can have available in many data centers. And that means apps in other data centers can call that REST endpoint and get the data locally. The data may be over here in California, but in Africa, they're querying it locally because it's been replicated locally to Africa. That gives you global availability, global scalability, with this simple little concept of just throwing the data in MarkLogic and instantly queryable. This is my conceptual architecture. We have third-party tools like ETL tools, Del Boomi, you've got Informatica, any third-party tool that says we have connectors, NiFi, whatever you want to use, they need to integrate with the hub. You have REST, you have message queues. This is very important. We need to have all of these working with the hub, not just one of them, because all of our customers need data to get into the hub through different technologies. Some technologies can only do message queues. Some can only do flat files. Some are, say, you have to go to my relational database and get it. Some can do REST. And that's on the source side, and it's the same thing on the consumer side. The cool part of this architecture is that the source can deliver data any way they want. They can send it through message queues or files. The consumer can get the data the way they need it. So I could send it in through a file, and then they could come through REST and get it. They could send it in through a message queue, then they could come through a file and get it back a big batch file. Or they could send it in through the app could write into MarkLogic directly through its REST interface, and then you could have a SQL database getting batch jobs pumped into it, or real-time changes. So you can come in any way you want and go out any way you want. This is the ultimate integration engine, and it requires an engine like MarkLogic, which is a REST database with JSON as its core. The tricky part is relational. So when you start with MarkLogic, you get REST, you get JSON and XML, you get message queue integrations because they all can talk REST. So you get this top half from message queues up. You get all of that with MarkLogic, and it's fantastic. There's nothing else in the market that can do what MarkLogic does in this space. I mean, you just literally just load the documents, turn the filtering on, you're queryable, you're good to go. The bottom half, MarkLogic just files great, right? MLC. So the one place that MarkLogic doesn't do great is relational, because relational doesn't play nice with JSON or XML. So this is our architecture that we're proposing, that we've built several times in pieces. Right now we're currently building the one on the right, a relational connector to MarkLogic. Keith's working on that right now. So because we need to quickly push data out to relational databases. Now we're looking at NiFi and some other things to see if that's simpler or better than what we're building. We've already built, and we're enhancing this piece on the left, on your left, where we're pulling data from relational into MarkLogic. So the goal is in our current code, you literally just point to a database, here's the tables I want you to bring in, and it sucks them in as is. That's easy. And we built a high performance solution for that. Getting it out is a little harder because JSON is hierarchical and you have nested tables in there. And you have to then say, how do I get this nested table out? And then in JSON, you don't have primary keys on your nested tables. They're just items in an array with no keys. So that's a problem. So you have to generate keys. And then the next time you go to update it, you have to go, what was the key I generated last time to make sure I update the right thing this time? And so there's some getting JSON to relational is harder problem. In order to answer the question about how do I map the key transformations, generated keys, and how do I get to the same key next time, means you need a database to store what you did last time. MarkLogic's a database. You can't do it in like just a coding tool. You need a database to store what did I do to get the result I want and save it off as metadata. And then the next time you look it up, oh, I did that. Now I can go replicate it. So when I look at tools that can change JSON into relational, most of them can't do what I just described because they don't have a database under them. They can do it once, but then they try to go update it. They can't update it because they don't know what they did the last time. They lost their memory. They don't have a database. MarkLogic is a database, so it makes it all possible. Okay, that's it. Let me go back to this slide. And any questions? I think it just totally went out of the whole thing. Okay, question.
Doesn't the TDE address the last issue?
Oh, it's TDE. The question is, doesn't TDE address this issue of connecting to relational databases?
Well, on the way out at least. Publishing it.
Publishing it. Yes, TDE can address it, but there are, I'll be candid, TDE has limits on how many, it's built on triples. The resources for triples are not unlimited, and the more you have, the more performance problems you're going to run into. So it's a scale problem. For example, in our MDM, we have thousands, or our data warehouse, we have tens of thousands of tables and hundreds of thousands of columns. MarkLogic's TDE can't scale that big. And you wouldn't want to. It's not built for that. When I talked to Stephen Buxton yesterday about this, it's built for document graph. MarkLogic's a document database with graph, excellent graph, but it's not a graph database with documents, right? So you do everything in documents, and then you'll connect the documents with graph. Perfect use case. But when you're trying to just do everything in triples, and I'm talking about creating our warehouse or MDM, and it can't grow that big. And you wouldn't want to. Think about what you have to do the work to create a table or a row out of combining all the work involved. It's just not designed for that use case. So yeah, that's my original idea. I wanted to have the SQL in MarkLogic with TDE, and then I realized, well, I can't get enough tables and enough columns to do it. But I can do it by transforms. And so creating a transform in MarkLogic is a piece of cake. You have XQuery and JavaScript are fantastic transform languages. And both are great. JavaScript is an unbelievable easy transform language, even easier than XQuery, which is awesome. So I've written transforms. I did a POC of this and showing our customers, how do you transform a really complex JSON document into tables? And that's out of the scope of this presentation, but I have the whole thing, and I showed them how to do it, and it was super easy. The code in JavaScript was 200 lines of code to do this complex transform, right? Piece of cake stuff in MarkLogic to do. And so transforming is a good answer, has been my answer. And then you can also do things like value add. We have harmonization and all that stuff. Great question. Any other questions? Yes, one over here.
Looking at this physical architecture, I'm not very sure if I understand it. How does MarkLogic, or what are the different patterns that MarkLogic would support from microservices-based architecture for different data domains?
I love your question. How does MarkLogic fit into a microservices architecture? Is that about right?
Yep.
So the wonderful thing about microservices is you're isolating all your REST endpoints to very small domains, right? And that you can really focus your code on being perfect for that, and you can be very agile and fixing each domain independently, right? That's a beautiful, for a developer, that's fantastic. Now, how do you join your data? If I have customer in one, and I have order in another, and I have product in another, and I want to ask the question, which products did the customers order from Nebraska, and the customer lived in Utah, right? I have to join all that data together. Microservices, by definition, have their own databases. They're completely siloed, and I can't join across them. So that means I have to pull all the customers out into an aggregate web service. I have to pull all the products out, all the orders out, and I have to join them in my REST service. And that's going to be so fast, because I'm talking about millions of things being over the wire and aggregated in my REST. I'm going to just love this with sarcasm, right? I mean, this is a horrible answer. Why would I ever love to bring millions of records across the network and try to join it in code? So what you do is you stick MarkLogic in front of your REST services. Have all your microservices down here, and then you put MarkLogic above them as the cache, and you cache their data from the microservices that you're sharing into the MarkLogic. MarkLogic has the indexes, MarkLogic can do the joins, and all that power I talked about is there. So MarkLogic is the perfect cache in front of your REST. So your apps do all the reads through MarkLogic and do all the writes to the microservice. So writes always go directly to the web service, but reads always come out of the cache, MarkLogic. That gives you the performance, the scalability, and all the benefits we talked about.
Yeah, but does that really mean then, if you are really using only MarkLogic as the database, document store, RDF store, as well as the cache for building different multiple data sets for the different data domains? Are we really talking about multiple such database instances within a forest, or how does it really scale when we have to really deploy true microservices-based architecture alongside different applications?
So how can MarkLogic scale as the cache in front of web services, right? Or microservices. So MarkLogic has built-in the ability to replicate itself. So your microservice would publish into MarkLogic the data that it wants to share. It doesn't have to publish all the data. Sometimes data is private, right, for an application. But the data it wants to share, it publishes into MarkLogic. So if you have 20 microservices, they're all publishing their data into the same MarkLogic database. So you can join it together and leverage the harmonization, the collection of all. You can search across them, join them. Then MarkLogic has replication. So you just use MarkLogic replication out of the box, very easy to set up, and you have another instance. Now you're twice the reads. You want a third one? Replicate again, 3 times the reads. Right? So you can replicate. I've never tested how many times you could replicate MarkLogic before it reaches a limit. There's some physical limit, and there's network limits. I don't know, do you know, Chris, how many times you could replicate a MarkLogic? You could build a replica tree. So with the replica tree, there's probably no limit then, no practical limit. So you can replicate MarkLogic like crazy then. I love the tree. That's brilliant. So you just replicate as a tree, right? And you can replicate the replicas. And then that thing will just scale out to be as huge as you want. But you don't need to, MarkLogic for reads is so fast, you don't need to replicate very much, right? So this is a massively scalable architecture without a lot of work.
Okay.
Yes?
On the replication, is this a synchronous replication or asynchronous, or what kind of technology you use?
So MarkLogic, what kind of replications does MarkLogic have? It has synchronous and asynchronous. If you're in the same data center, you can use, if you really care, you could use synchronous if you want it, but you don't need synchronous in this use case because MarkLogic is consistent, and asynchronous is always consistent too. You're just a lag time. But if you're in the same data center, your lag time is going to be very small. So it all depends on your app. If your app has to have sub-millisecond, if the replica has to be within sync in sub-millisecond, you need to do synchronous. But that's an unusual use case, so you could use asynchronous. But between data centers, asynchronous. Yeah, MarkLogic can do either one, so you choose.
So you can do it at tree level. That's a good thing.
Yeah, isn't that cool? I didn't know that. Yes.
Well, this will be a bit semantic. For me, this is a federated approach with a cache. So I did something similar, but I did it with another technology because I was dealing only with triples. I did the federation approach where I only sync the relation, but I leave the attributes. So the data set in the cache is much smaller. And then I only have to sync those and stay in the... You're basically syncing everything. So how do you deal with the reconciliation process? Because you may get out of sync.
So if you get out of sync, and almost every synchronization system does at some point, then you have to batch load and start over again. So that's That's where all these technologies here, if you notice, there are 4 channels I have. You can come in through REST or file or relational or message queue. Message queues and REST are not good batch mechanisms. Files are awesome batch mechanisms. So MarkLogic, the goal, what you do is you start a synchronization and you use normal replicas or you use message queues and you're synchronizing data. Something goes wrong, then you need to be able, from your source, be able to batch load, bulk load your data right into MarkLogic and start over.
You start from scratch, so you don't have a process that does it and find the deltas and just change. So how long would it take in your company to actually restart MarkLogic full? So that means you're down for a while, no?
No. So the goal is, the first pattern I showed is every app has their own cache. You don't have to have a central one for everything. If every app has their own data hub or cache sharing data, then it's just the app's data. The other part is, in our relational view, if you're getting it from a relational database, then we can do deltas from the relational. But if the problem, here's the point. When you first start, you have nothing, so you have to populate your cache. So that's a bulk load. You either do it from file or from full table scans of your relational tables. After that, you have a synchronization process where your app is just pushing it in. As long as your app doesn't go down, you're great. When the app goes down or you have problems or you get out of sync, purge your cache. There is some downtime at that point, but not totally. Where would your F5 would then route, instead of to your cache, it would route straight to their REST endpoint that they're delivering the data. So you're caching their REST endpoint. So you fall back to the original REST endpoint that you're caching. Does that make sense? The app should have a REST endpoint that is sharing the data, and it's then taking the exact thing it's sharing here and putting it in MarkLogic.
It makes sense if you're not doing a join across all the REST points.
Yeah, well, yeah, if your consumers are joining and you're down, you have a problem. The cool thing is if you get out of sync, you're not really down, right? You're up, you're just out of sync. So you could keep the out of sync version up, stand up another MarkLogic instance, do the bulk load, and then swap them. So because you're not dealing with a messed up source database, you have a cache. So you can do all kinds of tricks. But you do have to think these things through, right? You have to think through, what are my use cases, what do my customers expect, what are my available SLAs, my service level agreements, so I can deliver what the customers want. So you don't do this haphazardly. It is easy. Like I said, we stand this up in hours, but think it through so you make sure your customers are happy. That's where humans come in. We get to do all the hard work and thinking. That's why we get paid. All right, I love that part. Any other questions? Are we out of time? One more question? Yes.
You did mention about relational templates not being scalable or efficient. Now, and the alternate could be shaping data using JavaScript. Are you suggesting that we can we harmonize it into a JavaScript shape, using JavaScript into a physicalized shape and then query across that? Is that what you suggest?
Yes. If you want highest performance, you have several options. Okay. The highest performance option is bring it into the hub. Either have the app push it exactly the shape you want it to be, then you don't have to do anything. That's number one. If the app says, I can't push it to the way, I'm not smart enough to push it the way I want you to have it, then you can run JavaScript or XQuery in MarkLogic and shape it the way you want and save it. And then MarkLogic is super fast because it's just doing queries. You're not reshaping. But if you don't want to do that, you can load data as is from the sources, like relational, with all the tables. Then you can run like MarkLogic hubs and you can shape it all together using XQuery and JavaScript and deliver it. So there's several different models. If the app source is good data, and app sources are usually good data, I don't have to harmonize or doing all that stuff. I just want their data as is, and I want to share it exactly like their REST endpoint has it. I want to share it that way because they went to all the work to figure out a REST endpoint. I want to take that. I just want to cache it in MarkLogic to get all the benefits.
Okay. Thank you.
But you can do all the above. I guess that was it. Thank you very much.